This video is going to show you how to find points on a circle in radians, except the circle will not be the unit circle. Circle O is given by the equation x squared plus y squared equals 4. An angle with a measure of 5 pi over 4 radians is in standard position. If the terminal side of the angle intersects the circle at point B, what are the coordinates of B? So I have x squared plus y squared equals 4. So that means that my radius is equal to 2. So I'm no longer on the unit circle. If I was on the unit circle, instead of x comma y, I could use cosine theta comma sine theta. But since I'm not on the unit circle, I need to do something a little bit different. The unit circle had a radius of 1. My circle, or this question circle, has a radius of 2. So it's been multiplied by 2. So we're going to take our point, x comma y, and multiply it by 2. So instead of cosine comma sine, it's going to be 2 times cosine comma sine. So I have 5 pi over 4 radians, but I need to convert that to degrees. So I know that 1 radian is equal to 180 over pi degrees. But I don't have 1 radian, I have 5 pi over 4. So I'm going to multiply the left side and the right side by 5 pi over 4. It's an equation, so I need to keep it balanced. There is another video on converting radians to degrees, so if you still need help with that, you can check out that video. So 5 pi over 4 is equal to, on the right side, my pi's cancel. In my calculator, 180 times alpha y equals 5 over 4, and I get 225. So 5 pi over 4 is equal to 225 degrees. So on my circle, I'm going to be in quadrant 3. This is 225 degrees. Because remember, we go 0, 90, 180, 270, 360. So this is the point here. It's going to be a negative x and a negative y because I'm in the third quadrant. My reference angle is going back to the x-axis, so it's this angle here, which is 45 degrees. So I need to do 2 times negative cosine 45, comma negative sine 45. So from your exact value chart, cosine of 45 is radical 2 over 2, and so is sine of 45. Now I need to distribute. Remember, this 2 is technically over 1. So when I distribute, I'm going to get negative 2 radical 2 over 2, comma negative 2 radical 2 over 2. And my 2's are going to cancel here and here. So my final answer, the final coordinates of point P, are negative radical 2, comma negative radical 2. So same thing as when we're in degrees, except there's one extra step. You have to find the degree measure from the radians first.